Well, counting has become really important in what we're doing. We had the fundamental counting principle where we could count our choices with a multiplication that was going on. We could count things continuing up. So right, when we had the number of choices in one event and the number of choices in the next event, our fundamental counting principle said we multiplied them together. And so what we want to do is we actually want to talk about counting our sample spaces and our outcomes. And sometimes our outcomes can get large. So what I'm going to do here is I'm going to look at 3 colored objects. And so I'm going to make one green. Okay. I'll make one green. I'll make one pinkish red. And I will make one blue. Let's see if I have a good blue here. There's a good blue. And so these can represent something that is making up a sample space, and we want to look at sampling. And so the first thing we're going to look at is order. And order we talk about in terms of permutations. Think that mutation is in the word, and we're looking for how the different orders can come about. So I started with a green one, and so this is my first order. This is one ordered outcome. And we can look at it this way. I have 3 things. I pick the first one. It leaves me 2 to choose from. I pick the next one. It leaves me 1 to choose from. So coming back to my original, when I made that second pick of 2 to choose from, right, I picked one, I have 2 to choose from, I decided to do the pink. Now I pick the same one. I only have the blue or the pink, but I've already chosen pink. And so that's another possible ordered outcome. Now, if I choose green again, I'm only going to get a repeat of these outcomes. So I'm free to choose, and I'll choose pink. Now I've picked pink. I have 2 options left from my 3 different colored things, the permutations I'm building. And so I'm going to pick blue. I'm going to try to do these in a fairly order. But once I've picked blue, my only other option left is my green. Well, from pink, I could have picked green second, which would have left me with my blue. And so now I've had both patterns where I started with green and both patterns where I started with pink. Well, now I'll start with blue. And I have 2 options. It can be pink or green. I'll pick green. And then I'll end with pink. And then in my last blue, well, I've already picked green second, so I've got to pick pink second. And I end with green. And I've now chosen every permutation of 3 objects. I think the way a lot of this time this gets described in statistics books is if I put 3 balls in a bag and I pick them out, what are all the different possibilities? And so notice this is a sample space. This is all the outcomes I can have if I put 3 different colored balls in a bag and I pick them out. These are all the possible outcomes of those 3 choosings. And to find this, I'm actually looking at a counting principle. Notice what I said. I choose the first ball. Well, I choose that out of 3. But once I've picked it, I only have 2 options left. Well, just like my menu option, choosing chicken, rice, and my desserts, right? My fundamental counting principle. But as soon as I pick the second one, it locks in the first. And that gives me 3 times 2 times 1, or 6. And look, I have 6 permutations. And so this multiplication of permutations is called the factorial. And we usually represent it with an exclamation point. And what it does is it does the number n times n minus 1 times n minus 2 all the way down to 2 and 1. And so it's a series of multiplication, and it's multiplying all the different possibilities. Our calculator has a key for this. On the TI-30s, there's a probability button, and it'll give you a menu where you can scroll to the factorial. You want to type the factorial in first. And let's see here. Let me get my calculator up here. So if I come on, let me quit out of the screen I was in here. If I want 6 factorial, so how many different permutations of 6 distinct objects I can do, I come into, I want to say, is it in that? Nope. Whoops, I just want that. Yeah, I want to hit the math key. Sorry, I was just doing distributions, and so thought I saw it in distributions. And I come over to the PRB key and down to exclamation point. And that gives me 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. And that gives me 720 possibilities of 6 different things. Let's think about what we can do with this. For example, there are 26 letters in the alphabet. So if I were to pick one letter at a time in a weird pattern and use every single letter in the alphabet, come over to probability, down to exclamation point, and notice the number I get, 4.03 times 10 to the 26th. The e to the 26th times 10 to the 26th. The amount of permutations rise quickly. The 10 numbers that we have in our digits 0 through 9, if I were to pick one number at a time out of 0 through 9, and whoops, back here, sorry. My key, if you hear me thumping, my keys are sticking a bit too. So math, probability, down to factorial. And so I have 10 numbers in a bag. I'm going to pick them out one by one. And that's how many different numbers I can get out. And that would be, 1, 2, 3, 0, 5, 8, 6, 7, 9, using each one. Notice how a very limited number of choices gives us a large amount of permutations rather quickly. Having the ability to calculate permutations is going to help us, because our probabilities are sample space and outcomes. We're counting things, and the things we count can increase quickly. So if I have n distinct items, come back to my blackboard here, n distinct items, like 3 distinctly colored balls, then in 3 factorial is how many permutations or how many different outcomes I can generate from that. And so I could say, hey, of these, how many of them have are pink, blue, and green? Well, that's 1 out of the 6. And so my probability of drawing those 3 things, as if it were a lottery ball, would be 1 out of 6. Because I have one outcome in a sample space of 6. And permutations are really going to play a role in counting. And I'm going to continue where we're going to choose a subset of distinct things and find the numbers we get. We're going to say that we're going to say NPR. We're going to choose permutations. But for now, here's our factorial.